for your valuable time. Your time was 6 o'clock. So that is the your timely. Don't worry, don't worry. Anytime. I'll do another presentation if you like. Okay. As long as it is time for yes. Okay. Thank you.
Professor Kundu,
Yes, sir.
has Professor Bera joined?
Yes, sir. That's why I'm checking.
Acha, acha, acha.
No, sir.
Watch. Shuchishmita ma'am, Professor Shuchishmita Das ma'am.
Sir, she is not present in the meeting now.
I see. Mhm. Okay, wait for 2-3 minutes, or you have to then call. You have the phone number, na?
Yes, sir. Yes,
Professor
sir.
Beras.
Yes,
Yeah.
sir.
So wait for 2-3 minutes if he doesn't join, or just send a reminder that so the meeting has just started. So when you're joining, that's it.
Yes, sir.
Approve has যেতে পারে you understand? So that is what it is.
So good afternoon.
Has Professor Bera joined?
I don't know, sir, whether he
No,
has
sir.
joined or not.
No, sir. He have not joined. I have sent him a reminder. Now I am calling him.
Call him. Call him. Call him.
Let's call him.
All the sessions so far are going wonderfully, Professor Roy.
Yes, sir. Yes, sir. Yes, sir.
Professor Kundu, are you speaking?
He may be on phone call, sir, I think.
Yes, yes, yes. He must be on phone calls.
Yes.
All right, no problem. All right. It looks like Professor Bera will be held up for some time because he has certain exigencies there. So it is a very difficult situation. I will get back to you after I speak with him. Just a minute.
Okay, sir. Okay, sir. Okay, sir.
I will get
Okay.
back. I will call him.
Okay. Okay.
Dear participants, it looks like there are certain exigency happening at Professor Bera's end. We were contacting him, so we will come back exactly at 7. Now it is 7:40 in 10 minutes. 7:50. We'll come back after talking to him in 7:50, and you know how we are progressing. Okay. We apologize
yes.
for the delay. But exigency, I don't know, maybe it is a family exigency or something. Suddenly it has happened. and we'll get back by 7:50 with our plans and whatever. I will talk to him now. Give
Okay,
us
sir.
10
Okay.
minutes. Yeah.
Okay.
Uh, Professor Kundu? Professor Kundu?
Yes, sir.
Yeah. Actually, Professor Bera will be joining soon. Mane he's having certain exigency, but he said that exigency is about to be over. He will join in half an hour's time. But in the meantime, what I'll do is I have told him that I will give some initial discussions overall about emerging technology. So what I have done is I have sent you a presentation. So you run the presentation. I will speak from here.
Okay, sir. Okay,
You
okay.
you share the screen and I will ask you to, it was my Engineers Day presentation. So I will use that here.
Okay,
And
okay.
I believe participants also will enjoy because it is a wide spectrum presentation.
Yes, sir.
And Professor Pera will join at around 8:15. Okay. In the meantime, I will run this. Explain this. Yeah, please.
Yes, sir. I am downloading it.
Yeah, download and send it.
Yes, sir.
We'll do it. Yeah. Professor Kundu, you upload the presentation.
Yes, sir. Yes, sir.
Yeah. Dear participants, it is a test of the character and strength of faculty and whoever has joined the research scholars and all. This is a part, this happens in life that sometimes there will be unexpected things like this exigency has happened to Professor Bera, who will be soon speaking from IIT Bhubaneswar. But in the meantime, he has requested me to take up the first part or some general talk on emerging technology. So that I will do now. And hopefully he will be joining soon. And he said that by 8:15 he will join. And thank you very much for kindly be with us. We all are like say exigency can happen anybody's life, our personal lives. So I hope you would consider this case. With this, I would like to give a presentation. Interestingly, this was the presentation which I had prepared recently for Engineers Day, and the same presentation I would like to run to explain things. That is where it is here. Um, uh, just a minute. Yeah. So. So, acha, I only problem is that just a minute. Please, point 5. Actually, this must be here. Anyway, because the letter is small, so I'm trying to find out if we can have a better this thing so that it is easier for me to speak from here. And so,
So is this the scarce?
okay. So no, actually the letters are small. So all right, go to the next slide, Professor Kundu. Just go to the next slide. No, next. It is regarding this. We'll go to the technology slide. Next. Next, please. Yeah. So, no. Previous slide. Professor Kundu, yeah. So here, basically, what we have been talking about, I am listing down that all the technologies we have discussed or will be discussing,
Sir,
and it is in one page. You can see all the technologies that we will either talk or have spoken already. So one by one, if you see that we have talked about, these are some emerging technologies. Of course, let me tell you one thing very clearly. No list of emerging technologies ever can be comprehensive or exhaustive, because there every day new technologies are coming. Am I audible?
Yes, sir. Yes, sir.
Okay. So every day new technologies are being developed, are being generated, and they are uh, being included in the packet of emerging technologies. Now, say for example, the electric vehicle, autonomous cars. These were not part of, I mean, these were not conceived, say, maybe 30 years ago. Conceived or not actually in the limelight in 30 years ago or even 40 years ago. But now, a electric car is a very common thing, and so even now people still are trying to figure out how electric car is behaving, how much is the cruising mileage, what is the um, how much time it takes to charge the battery. And there is a very interesting thing in electric car which is called range anxiety. I don't know whether you have heard the term range anxiety. This range anxiety thing was not part of the IC engine based cars. Now suddenly, when there was an electric car, people had an apprehension that the battery might get exhausted, and therefore the car will stop midway on the highway or on the streets, in a busy street, or maybe in the in a dark night, uh, mm, in a place which is rather solitary. That's called range anxiety. That how long can a car travel? Because see, other areas have already been discussed, so I thought that I will take up some area which is very interesting and which is very contemporary, and also electric vehicles, because there I found that there are many people from multiple disciplines, including mechanical, electrical, electronics, computer science. They all have joined civil engineering as well, because see, cars and transports, these are all so connected things. Now what is happening, I'm telling you, is that now range anxiety actually was created in the minds of buyers, that a battery might go off anytime and they will be stuck. They will be stuck. Imagine a situation, there is no charging session and the battery is exhausted, and there are not so many mechanics who can fix the electric cars. And so people simply will not buy because of these factors, which are mainly guided by the range anxiety. Then what people started thinking was that, okay, we in order to remove that anxiety from the minds of people, it is better to have a combination. So instead of uh, full IC engine cars, if we can have the IC engine and the electric battery based system in parallel, where the size of the engine will be much smaller, and that will be only used for cases where the battery is not either fully charged, or when if it is somehow disturbed or not functioning midway, so it can still pull the car to this destination, maybe home, maybe to a garage. So what got developed was a hybrid electric car, which is the combination of electric or battery based systems as well as IC based systems. So which is the parallel system. I will not go into much detail of this because there are many things, series parallel, etc. But please try and understand that now people have started realizing that okay, hybrid is fine. It will give us that advantage of by any chance if the battery gets exhausted, still we can reach our destination with the help of the engine. A much smaller. Why much smaller is still there? Because why first of all the electric car was required? Electric car was required because of environment adverseness reduction. The greenhouse gas that is generated through the IC engine based cars will significantly be reduced, expectedly significantly be reduced with the help of electric cars. But there is one small fallacy is, I don't know, I would like to hear from the participants that suppose if we do electric cars, which is being charged from the grid, what is the problem that anybody would expect or anticipate? Is there any participant? I mean, it's a very interesting discussion. So I just would like to know if I mean I hope some people would know, or some people might think and tell us what is the problem that you think of in this given situation. Anybody? Suppose I have to charge my car from the grid power, that is putting the plug in the grid power point and putting that to charge my car. Are we actually helping the environment to be green? Anybody? Anybody? Any response?
No, sir, I think it's not.
Why not?
Because the battery used in the electric vehicle, that is lithium polymer battery, but extraction of lithium causes a huge pollution, and another way it's charged by electricity that is also we get from the thermal power plants
Good,
basically.
very good, excellent. So that is here the secondary pollution that is happening. It is very good, excellent. It is called secondary pollution. So if we are drawing power from the thermal power plants, and from that if we are charging our battery, then maybe we are making the car green, but the environment is not green, because to charge the battery we are drawing power from the coal-fired boilers or turbines. Coal-fired boiler is actually sending the steam to the turbine, which is driving the generator and which is producing power. Yes, anybody is saying something?
Yes,
Anybody?
this is the exact point, because people sometimes telling about this green car or EV car, the pollution free, but this concept is not means correct, because the power that is
Absolutely, Professor. Yes.
power that is
Now, yes, that is why.
power.
Correct. Absolutely. So, what is the solution? Solution is that while it cannot be first you develop the renewable energy system, then you develop electric car. So, nothing in technology will wait for the other. All will be developed parallelly. So, on one hand, you also can see the electric cars are being developed, and similarly now people are putting giving thrust to the renewable energy. Now if we can generate energy, say for example through the solar system, solar photovoltaic system, that is, or say the wind power or hydel power or any other geothermal or whatever the powers are, those will be pollution free energy generation. And now imagine from that energy, if we hypothetically suppose that energy is 100%, hypothetically, and there is no coal-fired power generation, then even if you charge the battery, then there is no pollution because the secondary pollution is gone. Now the question is, as we are moving towards the electric car issue, parallelly the whole world, I mean, in the Scandinavian countries, if you see, there people actually are relying more on the renewable energy, including the particular wind energy or something. Here in India, we have a great advantage that we have a huge solar energy coming on our part of the earth. So what we can do is we can generate solar photovoltaic based generation. Also in some areas we can do wind power and so on and so forth. So renewable energy is another area where emerging technology can truly be used. So although we are discussing the cyber based system, but also these can also be powered through this energy related aspect in industry 4.0. Now here, just after saying this, we'll just trace that. And just a minute. Here we see that there was some interruption, it looks like. So the hybrid electric car, no, Professor, could you go back to the previous slide? I just would like them to see the entire list and then we'll come back to this. Yeah. So here, see the components that we have. Cloud computing is being discussed, AIML, robotics and automation, UAV, unmanned aerial vehicle, or drones, which we commonly call. These are coming under the emerging technologies or advanced technologies, and these are being integrated with the industry 4.0 system. Embedded reality, okay, extended reality, which the extended reality we have discussed, AR VR was being discussed, and as you know, the VR is the completely in virtual reality space, and AR in the augmented reality, that is when some physical objects are there, on that we put the digital layer to make it augmented reality based things. Now when these proportions get extended, we call it actually mixed reality, or all these terms, AR, VR, MR, is packaged into one common terminology called extended reality. That means reality is extended, so it is commonly called XR. So all these are components of industry 4.0. So I have just put in as an emerging technology, but these are all part of the industry 4.0. Then one interesting thing is that additive technologies, additive and smart manufacturing. Is there anyone who can tell us what is additive manufacturing? Can anybody just throw an indication what is additive manufacturing in a very simple language? Anybody, anyone among the participants? Anybody? Just what is this kind of a thing?
3D printing, like a general printing, but this will be in 3-dimensional.
Yes, sir.
Yeah.
Yes, sir. No, I mean, see, very good, but see a very interesting point. This is extremely interesting point because now if I ask three-dimensional things were being made for quite some time. Maybe if I use a turning center or just a lathe, in a lathe we can make a three-dimensional product. Can we or can we not? Hello, sir.
Yes, sir.
So just making a three-dimensional product is not additive. So what are the other aspects that will make it 3D printing or additive manufacturing? But this
Sir,
discussion
in case of printing also 3D systems is used. 3D
correct.
printing system.
Absolutely.
3D
What
printing
is
system especially.
correct? 3D printing system is actually additive manufacturing. So what is additive
Yes.
manufacturing? What is additive manufacturing? Because it's a very important part of Industry 4.0, rapid prototyping and manufacturing. So what is it? Why you are calling additive? That means, is there anything subtractive?
Yes, sir.
Is
Yes,
there
sir.
any manufacturing called subtractive?
Yes, sir.
Not sir, addictive.
No. Additive, this one, I am saying, is there anything subtractive? Addition and subtraction.
Yes,
So
sir. Yes,
is there any, what is that?
sir, actually, when we make a three-dimensional object, say I am making a model using a wooden stuff, then we have to cut it out from the outside.
All right.
and-
So when we are cutting things out, we are subtracting material, right?
Yes, sir.
Mainly, sir,
So
it is the fabricating systems.
sorry?
Fabricating systems. Fabricating systems. That
Correct.
means
Fabricating. So fabrication can be done by two things. One is
Hmm.
by
Cutting.
material removal or material
Hmm.
joining, right?
Yes. Yes, sir.
So if it is material removal, like say it happens in lathe or milling conventional, then it is subtractive manufacturing, right?
Yes, sir.
Because we are subtracting material. Now,
Yes,
what
yes.
is additive? Additive
Hmm.
is that we are adding material. Say simple, a cube. Let us understand a cube. If I have to
Yes.
make a cube, say from a bar that is produced in steel plant, a bar which is cylindrical bar, that's how it comes, or a plate. I cut that plate and I produce the cube, or I machine that bar in a milling machine, and by removing the material, we get a cube. Right or wrong?
Right, sir.
Right. If we
Right,
want to
sir.
make a cylinder, I will go in a very simple way. If we want to make a cylinder which is standing, say for example, vertically, so
Yes, sir.
what we do, we can produce the thing in lathe that we have seen.
Hmm.
Okay. So in a
Okay,
lathe,
sir.
we are producing, we are cutting and we are removing material. Ladies and gentlemen, please understand
Hmm.
this. This is very interesting. So we are subtracting. But now, suppose if I tell you, I want to make a cylinder, and you come and tell me, all right, what I'll do is, you give me 1 rupee coin, I will put 1 rupee coin, next 1 rupee coin on top of it, then another 1 rupee coin further top of it, and if I keep on putting 1 rupee coins, then a cylinder will be built. Yes or no?
Yes, sir.
So am I subtracting or am I adding?
Adding.
So this is
Adding, sir.
exactly so
So-
possibly this is not the way anybody has explained to you before. Now, this is how the additive manufacturing actually works. Actually, it is constructed layer by layer. First layer is a coin. Now, I am saying coin, but in actually additive manufacturing, the layer is much thinner. Okay. So it may be plastic, it may be metal, that when it is in molted condition and put in droplets on a surface, then it forms a layer. When the layer
Yes, sir.
becomes semi-solid, we put another layer on top of it. Then we put another layer on top of it. Now say, if I want to create a cylinder, a tall cylinder, then I create one circular thin, a layer. Next is another thin circular layer. Then another thin
In each
circular
layer,
layer.
you can find the different types of circulations. In each layer, there will be some different types of circulations, layer by layer.
Layer by layer, but the dimension is same.
Dimension is the same. No problem.
So if so what is happening? See the circular layer, it is increasing in the z direction or z direction, upward. So now through this addition, now this is additive manufacturing. So we are adding layer, another layer, another layer, another layer. So we are creating cylinder instead of subtracting. By adding, we are creating. So it is called additive manufacturing.
Okay, excuse me, sir.
Yeah.
Sir, Dr. Bera has already joined.
Oh, that's wonderful. I have covered 2 areas.
Yes, sir.
Participants, thank you. Professor Bera has joined. We are fortunate that we'll go back to him.
Okay, sir. Thank you.
These
Thank
two
you,
are
sir.
important. These two things that we discussed are really part of Industry 4.2. Very importantly, the additive manufacturing. Okay. Yeah.
Okay, sir. Thank you.
Yeah.
Thank you, sir.
Yeah. Sure. Thank you.
Dr. Bera?
Yes.
Yeah, Professor, everything is fine now?
Yes.
Great. Thank you.
Good evening, everyone. So
Despite
sorry for
your
the.
We are grateful that despite your exigency, you could join. Thank you very much. Thank you.
Yeah. Thanks.
Thank you, sir.
Thank you.
Yeah.
Yeah.
Please. Yeah.
So welcome, Dr. Bera. Should we start, sir?
Yes. So you can start the session.
Okay. So before the starting the session, so let me introduce a short biography of Dr. Bera to our participants. So Dr. Bera is Associate Professor of Computer Science and Engineering in India Institute of Technology, Bhubaneswar. He's completed PhD in Computer Science and Engineering from IIT Kharagpur. He had worked a postdoctoral research fellow at University of North Carolina, USA. Before joining IIT Bhubaneswar, Dr. Bera worked as a researcher at General Motors Research Lab and senior scientist at Infosys Lab. The major area of his research is network and cyber physical system security. He also works on designing protocols for software-defined networks and applied cryptography. He has more than 13 years of experience in his domain. Dr. Bera led network security research group in IIT Bhubaneswar, consisting 20 undergraduate, 10 postgraduate, and 6 doctorate students and project staff. Dr. Bera has a large number of project funding from government agencies like DRDO, CPRI, MEIT, and industries like Bharat Electronics, Cisco, WizHack Technologies. He has published more than 70 research papers in reputed journals like IEEE TDSC, IEEE TNSM, IEE TSG, Computers and Security, and conferences such as Infocom, CCS, etc. Dr. Bera served in editorial board and organizing committee of various journals and conferences. He is a member, IEEE member, SEM. Dr. Bera has research collaboration with various international institutes such as University of North Carolina, Carnegie Mellon University, University of Missouri, Oxford University, and Florida International University. So this is the short biography of Dr. Bera. Now, Bera, the session is yours. You may continue.
Yeah. Thank you, Professor Roy, for introduction, and it's a good evening to all the participants, all the organizers. I'm extremely sorry for joining late. Okay, so I'll straight away start my session. Let me share the slides. Yeah, so
Okay.
So can you see the slides, participants, and you see that slides are changing?
Yes, sir.
Yeah,
It's visible.
yeah.
And can you see the slides are moving, changing?
Yes. Yes, sir. Yes, sir.
Okay, all right, perfect. So yeah, today we are going to talk about application of machine learning in intelligent intrusion detection system, or artificial intelligence in intelligent intrusion detection system. I'll set the context before I move to the topic. Okay, so this is the scenario today. All the services which we use, okay, mostly dependent on internet based computing and communication, like you for your utility billing, for e-commerce, right? Any transactions, financial transactions, healthcare, many applications today which we use, they are heavily dependent on internet based computing and communication. More importantly, we use cyber physical systems in many of our day-to-day applications. Sometimes it is little advanced applications. We face different types of cyber physical systems, or we use different types of cyber physical systems. For example, you have smart meters installed in your home, which basically has different sensors that collects energy usage data of different electronic devices in your house. So everyday energy usage data, they are basically collected and by the smart meter, and then they are basically sent through Wi-Fi or other network mode. So it is transmitted to the server. Server is a remote server which is placed in energy service provider office, let's say power grid. Okay, so or OPTCL, so different WBPDCL. So all this energy uses data, they are basically through wireless. It is sensed by this smart grid, smart meters installed in your house, and then it is basically transmitted to the energy service providers server. And they are basically, these energy uses data, they are basically analyzed for different purpose. So for example, for billing, or for understanding what is the demand of the electricity in a particular region, particular area. If there is any huge surge in electricity in a particular area, so those kind of analysis can be made based on this data, which are basically transmitted periodically from the different houses through this network, right? So this is a example of a cyber physical system, and then basically, depending on that, some control commands also can be sent to the smart meters, right? For different control actions, right? For example, if there is a huge charge in electricity in a particular area, and that is abnormal, then the corresponding meter can be stopped from the network, can be detached from the network. Okay, so many different types of control commands can be sent, okay, from the energy service provider office to the respective uh, smart meters, right? So this is an example of a cyber physical system where you see there are physical devices, and these physical devices functionality are controlled by some remote server, and that is basically the sending the signal or communication through internet, right? So this is an example of a cyber physical system. Similarly, there can be robotic systems, industrial control systems, healthcare telemedicine. Doctor is sitting remotely and is diagnosing the patient. So the patient's report, the medical reports, etc., those are observed, okay, remotely, and based on that, different, you know, diagnosis and medications has been prescribed, and that is also example of a cyber physical systems, right? And then in fact, there can be different devices which basically measures the parameter, physical devices which measure the parameters of patient's health records, and those can be communicated to the doctor who is remotely placed and doing the uh, uh, diagnosing the patients, right? So these are some examples of cyber physical systems. So here also you see that the data is actually, and data in different form, they are basically data or control commands, so they are basically communicated through insecure communication channel, right? So obviously, if in such kind of scenarios, how do you basically protect your data? How do you protect your system? How do you protect your network, right? So this is very essential, and today cyber security is one of the important requirements in all the organizations. Like I am talking about industries, mostly industries are they are very much sensitive in this part, so they are deploying various advanced cybersecurity solutions to safeguard their data resources and so on, right? At the same time, other organizations, government agencies, and it is very very important. Now, if you try to understand that what could be the potential footprint of different types of cybersecurity violations, so there you can mostly classify into three different categories or three different uh, dimensions. One is in computing platform. There can be different security violations. Another one in network infrastructure. Another one is administration and planning. So in computing platform, mostly it is like the attacker's objective, or the intrusion's objective is to disclose and modify sensitive data, okay, such as active memory, program execution path, network configuration rules in your computer or network devices. So these are sensitive paths, so they are basically modified and disclosed. They are disclosed and they are basically modified, so in the computing platform. And in the process, the unauthorized connections can be established with the computing platform, and that basically may create damage to the computing environment, right? So this is an important dimension. So where mostly you have active memory, program execution path, control, and network rules. These are basically the target of the attack. In the other dimension, there is network infrastructure. So here mostly not a single computing device, rather, or platform, rather a whole network connection of different devices. They are basically the target. And in fact, a recent study by NIST, National Institute of Standard and Technology, they mentioned that 65% of today's cyber attacks are due to network misconfiguration, network device misconfigurations, and that is a serious challenge, right? So here actually it's not a single device. You configure different routers, different switches by writing different rules, right? Configuring the IP, configuring access control rules, configuring NAT network address licenses, and various ways you configure this device. But when you basically uh, try to enforce a particular security requirements in those devices as a whole, right? You cannot configure the devices individually. You have to configure the device keeping the other devices are also around. keeping those devices in mind, right? The configurations of one device might create damage to the whole network, or misconfigurations of a 2-3 devices. If they are misconfigured, then the whole network may collapse. For example, I'm giving a simple example. Let's say there is a rule that is mentioned. There are 3 nodes in the network: network node A, network node B, and network node C. It has been mentioned that node A to node B, SSH or remote terminal access is permitted. That means computer A can remotely connect to computer B and then get access to that platform, the computing device. So remote terminal is permitted from A to B. And B to C, internet access is permitted. But from A to C, internet access is not permitted. Right? Let's say C is the web server. So B to C, the web access is permitted, but A to C web access is not permitted. Right? But here you can see that because from A to B there is remote terminal, okay, or SSH access is permitted, then the terminal A can go to node B through SSH, and from there basically it can perform web access, which is actually not permitted from node A, right? So this is called hidden tunnel. So therefore, if you want to configure that high level policy that from A to C internet access is not permitted, and it can be, it may be more complex, like during this time period, okay, from this particular location. So different way you can configure. I'm telling you simple rule. So you can see that because of that you are not configuring the intermediate devices appropriately, there is a hidden tunnel, right, exists from A to C, and that is actually violating your requirement. And this is for 3 devices, a small network. But if you have millions of devices in a network, thousands of devices in a network, you can imagine that how many such possibilities, how many such hidden tunnel possibilities can be there. That will be huge, right? And therefore, it is extremely difficult for the network administrator who is configuring each of the network devices by logging into the terminal connected to the corresponding network device and then configuring it. And if it does show, basically there will be high chance of misconfigurations, and in the process there will be different types of similar kind of violations, and that needs to be stopped. So therefore, some mechanism, some solutions we need to come up with that will prevent such kind of, that will identify, that will prevent such kind of misconfigurations, or the potential security violations can be identified well ahead, and then accordingly remediations can be done, right? So and this is network level, and here the type of attacks: mostly denial of service, hijacking of server, network jamming, hidden tunnels, SQL injection. So these are very standard, well-known violations which basically occurs at network level. Okay. On the other hand, third one is administration and planning. Here mostly you see that most of the web portals, I mean administration side, mostly we use different web interface, right? GUI. Through this GUI we basically put some values, look at what are the actions that needs to be taken, right? Mostly all the administration and planning related activities, they are basically done through web, right? And they are basically PHP, ASP.NET, different types of software Node.js, different types of softwares, right? They are basically used for implementing these web portals, right? And if those softwares are not properly patched or upgraded, then basically the attacker may exploit the weakness of those languages, those web technology tools, to bypass the check, and basically they can get into the systems and do different types of manipulation. So this is also possible. This is because of uh, uh, you know insecure programmings and not use of upgraded software versions, and then that may also lead to different types of attacks like false information forwarding, denial of service, quality of service degradation, etc. So therefore, mostly in all cases, the cyber attacks that can be classified into these three dimensions: computing, network infrastructure, and administration and planning. Now you can see that intrusion is basically how we basically model this type of attacks in general. So we call it as intrusion. What is an intrusion? Intrusion is any attempt to compromise the confidentiality, integrity, and availability to bypass the security mechanism of a computer system or a network. That is called intrusion. So it can be at host level or it can be at network level. Any attempt by a remote machine attacker to compromise the confidentiality means the person who supposed to read the data, access the data, only he or she supposed to access it, nobody else supposed to access it, right? That is confidentiality. Integrity means if data is transmitted uh, at state X, it should remain at X when it reaches to the receiver. It will not be modified to X dashed. And availability is like all the services which are running in the server that should be accessible by the legitimate users or authorized users, right? So any attempt to compromise these three, right, we call it as intrusion, right? That may be at host level, that may be at network level. And intrusions mostly classified into two groups: external intrusion, internal intrusion. External intrusion, suppose you have a university campus network, and any attempt to compromise these three CIA of your network by any external machine or external entity, that is called external intrusions, right? External intruders do not have any authorized access to your network, right? On the other hand, internal intrusions, they have some users, some entities, they have some authorized access to the system, but they misuse these privileges to gain more privilege. Suppose I'm a chief information security officer, right? I basically have some access. When I go for leave, I give my privilege to somebody else, and some limited privilege, but that limited privilege is used by the corresponding person to get a higher level access that it should not do that. So then that kind of intrusion is internal intrusion. Similarly, like anything which is you have logged in as a normal user and then you gain the root access of the computer, right? So these are actually internal intrusions. So external intrusions mostly easy to detect because they are coming from outside of your network. So at the gateway level, if you can restrict those packets, then basically that can be stopped. And that can be done based on IP filtering, port scanning, etc. All those things can be done at the gateway level, right? Different mechanisms can be implemented at the gateway level. However, internal intrusions, this is extremely difficult. For example, I always give this example to these learners. So suppose you are going into the Rashtrapati Bhavan premises, entering Rashtrapati Bhavan premises, right? At the main gate, there are security personnel, right? What they do? So they are given some list that you check that nobody is carrying this, the person entering the premises, they are not carrying these items. So any explosives or anything which is not permitted. So a list of items are given, and based on that, basically they filter, right? At the gate level, at the main gate, there are security personnel who checks this, right? So this is called signature based analysis. So the security is given with certain signature of items, and these signatures are verified when you are entering. And if anything matching with this signature, then you will not be allowed to enter the Rashtrapati Bhavan premises, right? So this kind of filtering is easy. So when a packet is coming from outside of your network, you check the IP address, check the port number, check the different parameters at the packet header level, and there is a signature based rules are given at the implemented at the gateway router, that okay, these are the rules based on which we will be filtering. If packet is coming from this IP address range, or its header is this, or packet size is this, then basically, so is list of signatures, based on that basically packets can be filtered, right? So this is normally the job of traditional network firewall. So network firewall, they are implemented at the gateway level. They basically looks at and then they determine the intrusions, and then accordingly drop the packets or take the actions on the packet, right? So this is firewall, right? And like equivalent, like the gateway at the Rashtrapati Bhavan premises main gate, some security personnel, what he is doing, it is signature based analysis it is doing, right? But if some signatures are missing there, then Rashtrapati the security will not able to verify that, and therefore it may bypass. Normally that does not happen at the gateway at the gate level. But suppose now you are allowed to, so you are not carrying any such signatures, any such materials, right? So therefore you are allowed to go inside the Rashtrapati Bhavan premises. Now what happens? Now inside the Rashtrapati Bhavan premises, you will be going to different places, different locations, right? And there, identifying what you are actually doing. Are you doing something abnormal? That is very, very important. That is called internal intrusions. So you got access to the network some way, but then you are basically misusing it, right? So therefore, identifying that, what is your behavior when you are inside the Rashtrapati Bhavan premises. So you'll be seeing there are CCTV cameras placed across the Rashtrapati Bhavan premises inside, right? So that basically captures your movement, your behavior, and those data are basically sent to the server, and server does different analysis, intrusion detection analysis it is doing, anomaly detections, and based on that it is flagging, okay, so this is an abnormal behavior, this is an abnormal behavior, and if it goes beyond certain threshold, then basically it is said to be an intrusion, right? So that is called intrusion detection system, the one which is basically done by the CCTV cameras. So therefore, when a packet comes inside the network, right, so those packets needs to be analyzed, right? Those packets needs to be analyzed, so their content needs to be looked at and seen that if there is any anomalous string or anomalous content, and that can be basically identified and that can be flagged. And this intrusion detection system or anomaly based intrusion detection system, they are building that. Developing such type of softwares are not so easy, because we have to have over some period of time, you need to observe the behavior of the packets coming from our IP address inside the network, and then you basically analyze those, and then based on that, you basically detect that this is abnormal, or this is crossing certain threshold, so therefore this is abnormal, and thus then it is intrusion, right? And detecting that, implementing such type of softwares, intrusion detection system software, sometimes not easy, because there are distributed devices which are collecting the data from different locations, and those are basically sent to the server. Sometimes I mean to say that some devices, they might be able to understand the behavior of a person on that, in a particular context, but it might not able to capture the behavior of that person in the other context. I'm giving you an example. For example, if I say that behavior of a person in a institute campus and behavior of a person in a banking network campus, that might be different, right? So the software which is basically looking after the abnormal behavior in a in a institutional network, that same software might not able to identify the malicious behavior in a financial institution campus, right? Because the context is different, right? So therefore, it may be the case that, okay, so there would be softwares which are implemented at different, in a distributed manner, and they collaborate amongst themselves to identify the actual intrusions. So when packet is flowing from your institute network to bank network, or bank network to institute network, so institute network level filtering can be done by the one type of intrusion detection system software, but it will not able to detect if anything related to finance network. So therefore, it needs to collaborate, send the packet to the institution network, and there basically it will be identified, or the packet information, and then accordingly these two system, they basically collaborate, software system, they basically collaborate, and then they find that this is a potential intrusion or not. So sometimes you may have distributed implementations of the intrusion detection system software, and that is important to bring context into the picture, and for better performance as well, right? So this is the context of intrusion detection system. And if we talk about different types of intrusion, so these are very well known: denial of service, man in the middle attack, IP spoofing, right? So someone's IP address is spoofed, and that is used for connection establishment. Port scanning, what are the applications which are running in your machine, that can be scanned. So you download some software, along with it some cookies gets downloaded, and then basically that software is scanning all the ports which are open ports in your system, and those data are sent to the through to the attacker's machine. The attacker knows that, okay, these are the ports which are running, that means these are the applications which are running. For example, if I say port number 23 is open, that means attacker knows that telnet application is running, right? Port number 8080 is open, that means web application is running, right? So it does the scanning of the ports, which are the ports which are open. Log into the your Linux operating system, running some commands, it knows that what are the open ports, and these informations are exposed. In the process, attacker knows that these are the web application, these are the applications which are running, and attacker also knows that, let's say there is a BitTorrent application running. Attacker also knows that there is a vulnerability in this particular application, and attacker tries to exploit that to get into the system and try to compromise the resources in that machine or in the network, right? So this is kind of port scanning. Then UTR, user to root, already I said. You log in as a user and then get root access. Asymmetric routing, scene flooding. there are different types of intrusions, right? And yeah, so I'll skip these things. And then more importantly, today we are not only using these devices, only normal network devices where the computing devices, they are connected to the network, they are sending packets, normal network packets, right? File as a file or image, right? Similar kind of. We also have many applications today, they are based using drones, right? Rapid adoption of drones, okay, that is actually very very challenging, because those are used for surveillance, delivery, inspections, so especially in defense applications, right? There were different agricultural application, control center applications, weather forecasting applications. So UAVs are widely being used, right? Now, whatever the data they are sending to the ground control center or ground control stations, right? So that can be modified, that can be malicious data, and in the process that can compromise the functionality of the overall system, right? So safety, privacy, and mission integrity are very very essential when these drones networks are there. Sometimes, I mean, I may be interested to know that, okay, this is whether the drone which are from other country, or so it is flying, I want to identify that whether it is it is sending this, it is other country's drone. So it basically sends comments, they send signals to the nearest access points, and then from there we can capture various metadata, analyze them, right? Lot of informations are there, so we can analyze them, we can identify that whether they are, you know, malicious or not, right? So many of these drones, they operate on hostile and untrusted environment. Successful malware injection can let attackers hijack drones or steal their data. So if an attacker can steal, hijack some of the drones or steal the data, confidential data, right? So that is possible. How you can basically stop it, right? In general, the threat model and attack surface are like, there are what are the different types of attacks that can surface in this kind of scenario. That study is very very important, right? Remote command and control links, which are radio Wi-Fi links, they can be intercepted or spoofed. Ground control station can be compromised. Supply chain software updates, so drone firmwares or patches, those are actually need to be upgraded, right? Otherwise there would be malicious there will be vulnerabilities which can be exploited by the attacker to extract informations from the drone, the softwares which are running. So sensor spoofing and data injection, GPS spoofing, false telemetry, physical access also, before deployment tampering can be done. So these are different types of threat model or attack surface. So attacker objective is to take control of the drone, steal the data, stay hidden, and disrupt the complete functionality of the system, right? So there are various ways malware injections that can happen, like firmware trojans, boot time persistent rootkit in boot, or RTOS, real-time operating system layer, application layer malware, man in the middle attack, so that is also possible, right? Then side channels or covert channels, so it analyzes the timing informations of communications or computing at the UAV level, and then it tries to understand that what algorithms have been used there, right? So this is very very important. Yeah, also poisoned OTA update, right? That installs a backdoor into autopilot. right? So this is something also very, very important. So this sometimes when you do installations, right, in the drone, so and it can actually create, if the softwares are not properly patched, it can create backdoor into autopilot, and in the process the control of the pilot can be taken. So over the air, if you want to do update or install some softwares in the drone, and then that can actually create a backdoor into autopilot also, right? So these are possible examples. There are different ways intrusion detection system that can be built for drones, like host based intrusion, network based intrusion detections, then hybrid approach, combined host based intrusion detection, like in a single drone or at the network of drones. So it can be done at the edge level or at the onboard level. Lightweight intrusion detection system can be done. It can be specification based or signature based. So in signature based, basically we use certain signatures, fingerprints. Based on that, basically intrusion detection system works. On the other hand, in case of specification based, you have some behavioral descriptions of the different softwares which are running inside the drone, and based on this behavioral analysis, if something goes wrong, that can be basically labeled as a intrusion, right? So specification based versus signature based. So these are different types of intrusion detection systems which can be used. And importantly, you can see that if so, what intrusion detection system does? It basically, let me go to that. So there are various data sets for drones in Kaggle. So those data sets are used for training and testing purpose. I'll come back to these after some time. Before that, let us try to understand that how basically a intrusion detection system works. What are the major type of intrusion detection system? One is signature based, as I have mentioned. So for example, a packet is coming from internet and there is a firewall. So firewall basically looks at the IP address, port numbers, and it says that it is permitted, so it allows the packet. But then when it comes to the intrusion detection system software, so it basically captures the data. It has three components. It captures the data, analyze it, and then basically it sends the signal that this is the result, right? It captures the packet from different routers, and then basically it send it to the intrusion detection system software. It basically analyzes it, and then it flags it, right? So that is how intrusion detection system normally works, software normally works. Three components: sensing, then analyze, and then reporting, right? But what it does, basically, you can look at this. There is a packet. Inside the packet payload, there is a string called surprise. So therefore, signature is header IPv4 protocol HTTP, destination port number 80, and signature string is surprise. So this IDS has a signature database. In the signature database, it basically maintains these keywords and so on. If anything matches to the payload, then basically that will be treated as a intrusion. So signature based IDS are very easy to implement. So they are fairly easy to implement and easy to update also. And they are also high accuracy. It provides high accuracy. Why? Because I have a limited set of signatures, X, Y, Z, some signatures are there. And whenever a packet comes, I check the packet payload and I try to match if anything, if it matches to any of these database signatures. And if it matches, then I flag it. Otherwise, I allow the corresponding packet to go for, right? So signature based IDS, because you have clearly specifying that what are the signatures, so there will be no chance of misclassification. So high accuracy will be significantly high. Low false positive rates. False positive rates means good packet is classified as a bad packet or malicious packet. That chance is also low because you are doing it based on signatures, list of signatures. But the major problem is zero-day attack. Any unknown attack cannot be captured by the, so something signature is not available. If the signature is not available in the IDS, then the corresponding, the small perturbation, if it is made in the packet payload, so it can bypass the signature based IDS. So it cannot identify zero-day attack there, right? So therefore, something we need to come up with, that is anomaly based IDS. What anomaly based IDS does, it does not compare, it does not check any signatures. Rather, it basically checks based on the observed event for a particular time period. It identifies that this is a normal activity and this is an abnormal activity. So therefore, anomaly based IDS, what it does, it observes the behavior of a person or of packets coming from an IP address or a machine. And let's say for 1 minute, it is observing all the packets, and then basically it sees that there is, if anything which is a deviation from the normal activity, then that is flagged as a intrusion. For example, TCP packets are flowing in rate 100 bits per second. UDP packets are flowing in the rate 112 bits per second into the network. ICMP packets are flowing in the average, on an average 43 bits per second rate. It has been observed. Suddenly it is seeing that there is a UDP packet which is coming at the rate of 425 bits per second. And that is an abnormal behavior. I am driving on a speed of 60 km per hour for quite some time, and then suddenly my speed increases to 140 kilometers per hour, right? And that is abnormal behavior. So we are observing the behavior, and then we are basically classifying that this is not abnormal activity. So therefore, normally for anomaly based IDS, there are two mechanisms used: thresholding or profiling. Thresholding, it checks excessive event occurrence over a time and compute statistics, certain system or network activities, and report if alert is, if it is out of range statistics, right? So this is threshold based. So it stores daily count of certain activities and for a particular time period, and then report anomaly if there is some bound exceeds. On the other hand, profile based, it characterizes past behavior of users and groups, and then detect signature deviation, any significant deviation, right? In case of profile based, right? So analysis method is like mean, standard deviation, multivariate analysis. So these are this profile based. Here basically there is a significant application of machine learning to build this profile based or anomaly based intrusion detection system, right? Using profile based approach. And here you can see that because we are observing the behavior for some time and then we are doing it, so zero-day attack can be identified. So if there is small perturbations in the speed, that can be actually identified properly, right? Zero-day new pattern of the attacks that can be identified easily. But obviously the problem is there may be high false positives, good packets. So you are defining an anomaly-based intrusion detection system, developing an anomaly-based intrusion detection system, and your rules or your profiling mechanism or your thresholding mechanism are very stringent. In that case, even good packets may be classified as a bad packet. So high false positive rates. So therefore, it has been observed that there is a potential lot of possibility of applying machine learning techniques. So if we have data sets available of good packets, bad packets in a particular setting, cloud setting, or in a Wi-Fi setting, or in a wired network setting, right? So if we have a lot of data sets, so those data can be used to train the intrusion detection system software to reduce these high false positives, right? So that is where basically machine learning comes into the picture. So normally for intrusion detection system, we use these two metrics, high accuracy and low false positive rates. We expect high accuracy, that is 2 positive plus 2 negative divided by 2 positive, 2 negative, false negative, sum of these. And false positive, yeah.
ఇది కూడా అంతే ఉంది.
Hello. Yeah, you have any doubt? Anyone have any doubt or any questions? So I'll be closing it in the next 10 minutes because I started late. I'll conclude in next 10 minutes.
Okay, no problem, Dr. Bera, no problem.
Yeah. So accuracy is basically measured in terms of this formula, and false positive rate is measured in terms of this formula. And what is true positive? The intrusions that are successfully detected by your software. Normal or false positive is normal or non-intrusive behavior that is wrongly classified as intrusive behavior by the IDS. So like that you can count and you can calculate. So accuracy and FPR are the major metric which is used for determining performance of intrusion detection system software, and we expect high accuracy and low false positive rate, right? And these are the data sets which are available, so you can Google it. These are available open source data sets. NSL KDD data set, this is 1999 data set, okay, 1999. This is pretty old data set, but this is pretty large data set. Lot of records you have, along with normal, denial of service, probe, UTR, different types of attacks, and normal packets. So the distribution is like this, and then you can divide it. Some can be used for training purpose, some data can be used for testing purpose, right? So this is NSL data set which is widely used, right? But because it is old data set, nowadays 2 more new data sets have been evolved. UNSW NB15, this is in 2015, and these data sets are slowly lot of more new records are being added, and AWID data sets. So here you can see most of these data sets are related to cyber attacks in Wi-Fi network or in cloud networks, right? So they are consisting of more different types of attacks. In NSLKD we have only 4 types of attacks, but here you have more different types of attacks that are included. Similarly in AWID also. So you can check those data sets, right? So I'll skip this part. So the detailed descriptions, their software definitions, all those things are available for these data sets. I will straight away quickly go to one approach which can be used, right, for intrusion detection system, right? And then I'll close there. So look at this. Here what we have done is, this is a architecture of deploying intrusion detection system. Here you have a subnet. Let's say this is your inside your campus network. This is a hostel network. This part is basically your academic network. There can be another subnetwork that can be connected your finance or academic finance network, right? So many computers are connected through routers in each of these small subnets, right? And there are routers. This red these elliptical curves boxes. So they are basically the you know they are basically the routers, right, which are networking devices which forwards the packet from between one node to another node and so on. So what do we do here? We have the training process running in all these routers. So we call it as agent logic. These routers act as an agent. So it collects all the packet coming from different hosts. So let's say host 1 is sending packet to host 4. Host 2 is sending packet to host 7. So all these are basically flowing through these routers, right? What router does? Router collects all these packets from the log, right? So those packets are basically used for testing purpose. Your intrusion detection system logic is running here. So what it does, essentially, it collects the network traffic and then it runs the agent logic, and based on that logic, it calculates some state vectors, generates some state vector, and these state vectors are sent to the central IDS, and central IDS basically calculates some reward for that corresponding state vector calculation, and then it sends back the data reward to the corresponding agent software which is running in the all the routers, and it modifies the training the network which is used here, machine learning network which is used here in the agent logic. And after some iterations it basically stabilizes, and then you send some training test packets to these routers, then it will able to identify that this is good packet or this is intrusion packet. Even if it is intrusion, what type of intrusion it is, it will able to classify, right? So you are basically training with the data sets first, and that is happening at the agent logic, and then basically you are sending the test data, test packets, to see that whether it is able to classify it properly or not, right? So this is the architecture which we basically consider, and the central IDS is basically connected with all the routers. So I'll show you briefly what exactly agent logic running, the logic that is running in the router. So what it does, it collects the network parameters and host parameters in a time window. In a given time window, all the network parameters of the packets which are flowing through, IP address, port number, host parameters like which operating system, which softwares are running in this host, which are sending the packets, all these parameters are collected. From their important features we are extracting. Which are relevant features we extract, we pre-process it, then we select the features, we generate feature vector. And these feature vector are passed through different classifiers. Let's say decision tree, random forest, different classifiers. We pass through it, we generate some classification vector. After the classification vector we get, we concatenate this feature vector and classification vector to get a state vector that is passed through the deep queue network. This whole thing is running in the agent. And then deep queue network generates agent result, and that is actually sent to the central IDS. Central IDS, based on this result, it calculates reward and send it back to the agent. Then based on this reward, if the reward is not promising, then central IDS updates these deep queue network parameters. The propagations of the classification feature results to the network is done in a different way now. So network parameters you are changing. So in the process, different network again will be basically doing the same process, same thing, and it will calculate again agent. It's sent agent result again. It is sent to the central IDS. This happens over the iterations till a promising reward is received. Then there it converges. The training part is over. Then basically you send the test packet. Now, if I see that what is the details of the in agent logic, this whole thing is basically running inside the router, right? So what it does, Same thing as I mentioned, it basically after feature extraction, feature vector we get, we pass it through different classifiers. C1, C2, CK, K number of classifiers. It generates classification vectors, CP1, CP2, CPK. And this classification vector and this feature vector, they are basically concatenated. Side by side concatenation happens. And now we get the state vector that is of also length K. And it is now passed to the deep queue network. So deep queue network basically based on this importance, it propagates through, right? Propagates this way and send it to the output layer. And output layer, some values therefore we are getting. And that is basically now here you are applying thresholding. If Q1 is greater than Q1 threshold, then Y1 will be equals to 0, otherwise Y1 equal to 1. Similarly, these are all, Boolean variables. Y1 to Yk, they are Boolean variables, right? So true or false. So we generate this, and that is the decision vector, which is further XORed with this classification vector to generate the actual action vector. And this action vector is actually sent from the agent to the server, central IDS. So this is the whole process which is running in each individual router. Every router is running independently this logic, right? And they are generating the agent result, and that is sent to the central IDS. Central IDS calculates reward, send it back to the router. Router modifies the model parameters, it runs it again, and it happens over the iterations. Finally, we converge, and then test packets are basically sent. Right? So this is the overall architecture, and in the server, basically it's basically based on ground truth. So it is like a sandbox environment. So it runs the corresponding result, and then accordingly it finds the reward, right, in the central IDS, and that is communicated to the agents, right? So now, so it's like a experience replay method, right? So server is basically act as a experience replay, agent, and it sends the experience to the local agents, and then they are basically updating their model parameters. And we have seen this also, like the classifiers which we have used, random forest, ADB, QDA. So on different data sets, we have done the experimentations, and you can see that there are accuracy and false positive rates. So many different things you can see, observe that for AWID recent data sets, accuracy is reasonably higher. These were pretty old data sets. That's why accuracy was not coming. And these data sets are giving better accuracy and low false positive rates as well. Right? But some of the classifiers are not providing good false positive rates, right? So based on these results, what we did for different data sets, we identified which classifiers are high accuracy and which classifiers are low false positive. By knowing that, we basically create combination of classifiers, and then we again run the experiments. Random forest, KNN, ADB, QDA, these four falling into a single class, C4. RF, KNN, ADB, GNB, they fall into C5 class. And we combine them and we run the experiment again. And we see that C4 classifier, combination classifier, it is giving good accuracy and very, very low false positive. Right? So that is really good. And that attack type wise also, we have seen that which classifier is giving better accuracy, and for different types of attacks. We can see that denial of service, this is pretty well identified, but for worm attacks, so this is not well identified across all the different data sets. So that may be because of lack of data, worm data, right? So these are also identified. Then we have also done some experiments on if attacker wants to make small perturbation. Let's say I say that this UDP packet 400 UDP packet limit is 843 beats per second, but attacker makes it limit is 43 beats per second. Attacker makes it 43.001. So now this can be classified as a normal packet. So attacker makes small perturbations on the data and tries to bypass your intrusion detection system. So for that, what we do, we also created adversarial dataset using Jacobian statistical approach. You have test data, label the test data, and then we apply Jacobian to generate adversarial data, and that adversarial data also we use to train the model. And then we see that if we apply this denoising autoencoder using adversarial data, so initially in adversarial setting where there are a lot of attackers, lot of attacks we inject in the system, before adversarial attack percentage was good, then after adversarial attack percentage falls down significantly. But then when we use this adversarial based training of our model, and then we see that accuracy improves, right? So that is where basically we did this kind of experiment, and this is a really important area. Lot of research are happening across different groups. In different groups, they are basically doing it, and more importantly, now there are different types of data sets, especially related to drones, which are available, and we are the attack patterns in UAVs, they are little different than normal network attacks, right? So threat model varies. So we basically look at telemetry logs, system logs, network captures, command control logs, all these data we basically capture: GPS, altitude, velocity, altitude angles, sensor status, memory consumptions. So these all informations basically we capture from the drone, and we try to understand that whether there is any malicious attacks through the drone, right? So we use anomaly detection, supervised classification, also this kind of machine learning models, but data set has to be really good. So drone based malware detection data sets in Kaggle, we have these data sets, then UAV SIEM, ISO drone anomaly detection data sets, drone hunter. So Colorado UAV test bed also available. So these are different tools which are available. So that can be actually used to generate the data set and use those tools for training your intrusion detection system, for identifying the malwares and intrusions through the drone network, right? There are limitations, obviously, because the drones are resource constant devices. The compute, memory, and battery power are less. So whatever solutions you come up with, that has to be very lightweight, right? Limited portability of signatures. Then there are adversarial attacks against ML detectors. So how do you basically generate adversarial data which can be used to train the models? Then false positives are also important, especially for mission critical applications. And these are also sometimes we generate synthetic data. So these are some best practices: secure boot or cryptographic firmware signing, encrypted or authenticated communication channel. So I'll not go deeper, because these are individual mitigation or best practices are itself area of research, or area of development further, right? So I'll keep these slides with you also if you want to pursue further study on this. And
Professor
yeah, with
Bharat,
this
that will be
I
very,
think
very
I
nice.
will conclude. If you
Yeah,
have,
that will be very nice if you can share the slides.
yeah,
That will be really very good.
I'll share the slides with all the participants. So I mean, probably I'll share through your the organizers, right?
Yes,
So
yes,
and then they can
yes,
you can
yes.
circulate.
Absolutely, absolutely, absolutely.
Yeah, and from there, yeah. I think with this I'll conclude here, making a statement that cybersecurity is one of the important uh, challenge in today's scenario, right? If you talk about uh, different cyber physical systems which are used in various sensitive applications environments, right? Starting from power grid, starting from defense, starting from industrial control systems, right? So we need to come up with very up to date updated solutions all the time, right? Because the attack patterns changes frequently, right? So we call it as zero day attacks. So obviously you need to come up with solutions which are more accurate and which are lightweight, very lightweight, like because we are going to deploy it in devices which are resource constant devices, right? So there are a lot of research in these directions that how to make it deployable solutions in practical environments, especially lightweight environments, resource constant environments. So uh, uh, that is really important research. So we need to really come up with good solutions to identify and prevent such type of attacks. Okay, so with this I think I'll stop here and I'll share the slides. Thank you very much for listening. If you have one or two questions, then I can quick questions so I can answer before the
Ex-
session's
uh,
close.
uh,
Now it is about to participant. If you have any question,
Professor Kundu, is there any question in the chat box?
No, sir, there is no questions.
Okay, okay. All right. Fine. I mean, maybe it is a bit here or there in the schedule.
Yeah,
That's
yeah.
why.
I think that
So
is because of that.
anyhow, that's so
Yeah,
that
yeah.
they
I
can
mean, they can connect. I mean, I'll be happy
they can
to
connect.
get
Yeah, sure,
connected
sure,
through
sure.
email also, right?
Absolutely, absolutely,
And,
absolutely,
yeah, thank you.
absolutely, absolutely. Thank you, Professor Bera. Thank you very much.
Yeah.
And just after the meeting, I will call you for just 2 minutes. Just after the
Mhm.
meeting, I'll give
Yes,
you a
sir.
call.
Sure, Professor. Okay. Thank you very much. Good night. Have a good night. Thank you. Bye.
Just a minute, just a minute. Formal closing will be done by Professor Roy.
Oh, okay, sorry. Yeah.
so thank you, Dr. Vera. So it is a nice presentation. So thank you very much.
Thank you everyone. Yeah.
Deepmoy Kundu, anything you want to say regarding queries?
No, there is no queries in the chat box. No one have asked any question.
Feedback
No, but
regarding
you
feedback,
have to give an instruction for the feedback on something.
feedback.
Yes. Thank you everyone for joining the session, and I have given the link for feedback for this session 8 in the chat box. Everyone have to fill the form. Thank you very much if you have already filled up the form. Everyone must fill up the form before leaving.
Okay, so Professor Roy, so should
Okay.
I leave the meeting?
Yeah, you can leave, definitely.
Okay,
Thank you.
Bye.
Bye.
Good night.
Okay, thank you everyone for being here. I think everyone have submitted the feedback form. So I am closing the session. Thank you everyone.